Okay, section 9.2, talking about mole relationships in chemical equations. Today we're going to talk about mole factors or ratios, and we're going to use those. Those come from a balanced equation, and that will help us to calculate moles of another substance. All right, a mole to mole factor or a mole to mole ratio tells us about the moles of two substances in an equation. So the first thing you need is you need a balanced equation, which here we have one. Two iron atoms react with three sulfur atoms to make iron 3 sulfide, sorry. And then the ratios come from the coefficients. So we know 2 moles of iron, 3 moles of sulfur, 1 mole of iron sulfide. We know from previously that the masses of reactants are the same as the masses of products, but the ratio of the number of atoms or the number of moles is different. A mole to mole ratio or a mole to mole factor is a ratio or a conversion factor of the moles of the two substances in an equation. So if I'm looking at iron and sulfur, I could set up two conversion factors, two ratios, saying that 2 moles of iron react with 3 moles of sulfur, or we could say 3 moles of sulfur react with 2 moles of iron. In either case, the coefficient from the balanced equation is the number that we use in the mole to mole ratio. So we could set up one between iron and iron 3 sulfide. We could say that 2 moles of iron react to form 1 mole of iron 3 sulfide, or we could say 1 mole of iron 3 sulfide is formed from 2 moles of iron. We can do similar things between sulfur and iron 3 sulfide as well. Okay, go ahead and get out your mole diagram. We're going to add to it today. We're going to take first and add the word known all the way across to each box, and you can add the word known here under particles as well. And this becomes our known substance or the given substance in the equation. What we're adding to here today in our mole diagram is we're adding an arrow going down and a new box called moles of unknown. In order to get from moles of known to moles of unknown, or substance A to substance B, we're going to use the mole ratio or the mole factor. The mole factor uses the coefficients of our two substances. The coefficient of the unknown always goes on top of the ratio, and the coefficient of the known always goes on the bottom of the ratio. So add this box to your mole diagram. So here's our first sample problem. The question then is, if I have 1.42 moles of iron, I want to know how many moles of sulfur are needed. So here's my balanced equation. Here, 2 moles of iron react with 3 moles of sulfur to produce 1 mole of iron 3 sulfide. So our given, or our known, is iron. So we were given 1.42 moles of iron. So that's my known. And then I'll start there at the top of my mole diagram, there in the center under moles of known. Then I need moles of sulfur. So I'm going to use a mole to mole factor, or the mole to mole ratio, to get us from moles of iron, which is our known, to moles of sulfur, which is our unknown. So here's our plan. We're going to take moles of known iron. We're going to use the mole to mole factor to get us to moles of sulfur, which is our unknown. Using our coefficients, we can write two possible mole factors. We can write 2 moles of iron over 3 moles of sulfur, or 3 moles of sulfur over 2 moles of iron. We always are going to put the known on the bottom and the unknown on the top. So this would be the mole ratio that we're going to be using. So then we're going to start with the number in our problem, which was 1.42 moles of iron. And then we're going to put our mole factor. We're going to put our unknown on top. So that is sulfur. So moles of sulfur on top, moles of iron on the bottom. The 3 moles of sulfur is the coefficient for sulfur, and 2 moles of iron is the coefficient for iron. So then moles of iron cancel, and I'm going to take 1.42 times 3 and then divide by 2. You got to do both, multiply and divide in this case. When I do that, I come up to be 2.13 moles of sulfur. So here's another sample problem for us. We're going to take propane gas, C3H8. Propane's used in camp stoves, soldering torches, such as the one shown down here. It's also used in your house if you have a big propane tank outside that heats your house with in the wintertime. Some cars and buses and big trucks sometimes can use propane gas. But in a combustion reaction, we have propane reacting with oxygen to produce carbon dioxide and water. The question then is, how many moles of CO2 can be made if I have 2.25 moles of propane? So here's my plan. I'm going to start with my known, which is moles of C3H8. That's the top middle of your mole diagram. And then we're going to go to moles of unknown, CO2, and that's going to be using the mole ratio from the mole diagram. So the first step, then, starting with the 2.25 moles of C3H8, and then I'm going to put the mole ratio in. The mole ratio is a ratio of moles, so it's moles over moles. What goes on top? That's our unknown. So CO2 goes on top. What goes on bottom? That's our known, so C3H8. So what goes in the, what numbers do I use? I'm going to use my coefficients from our balanced equation. Here's 3 for CO2 and a 1 for C3H8. So a 3 and a 1. So then I look at my units. Moles of C3H8 cancel, and I do the math. I take the 2.25 times 3, and I get 6.75 moles of CO2. So looking at significant figures, here I have 3 significant figures. A mole factor is an exact number, so it does not affect our significant figures, so my answer should have 3 significant figures. And that's it. That's how you use mole-to-mole factors or mole ratios to go from moles of one substance in a balanced equation to moles of something else.